Hey, hello there. Today's Leetcode challenge question is called H-index 2. H-index is a measurement to see how influential the researcher's work are. So it's an overall measurement based on all the papers that the researcher has published. So the scenario here is that we have a researcher who published a bunch of papers. For each of those papers, we look up the number of citations the paper has. So for that nature, the citation number are non-negative integers, either 0 times or some integer number of positive integer number times the other people cite this paper. So for all the paper that the researcher published, we collected those citation numbers and sort them in the ascending order. So we're looking at the least influential work to the most impactful work. We need to write a function to calculate the researcher's H-index based on those citations. So the definition for the H-index is that the researcher will have the index value H if exactly H out of his or her total papers have at least H citations. That's have citation number greater than or equal to this H. While the remainder paper have no more than, less than or equal to H citation. That's a little bit difficult to understand what this means. Let's look at the example. We have a researcher who published 5 papers. So the H index here is 3. It's easy to verify that. So the most influential 3 piece of paper, they have citation number 3, 5, and 6. So the length for this 3 paper here is 3, and the minimum citation here is 3. So we're looking at 3 papers with at least 3 citations. So that's why this person have a H-index value 3. The remainder 2 papers have a citation number 0 and 1. So 3 basically partition these papers into 2 sections. So how do we actually solve this if we just based on this kind of intuition? Since that the citation number are actually sorted, we're just going to use the definition to derive this H-index. So we're looking at the most influential work, saying that hey, until now we examined 1 paper and the citation number is 6. So it's strictly greater than the number of paper we looked at. Then in the next iteration we're gonna move towards left by 1. So we examined the most top 2 papers for the person. The minimum citation is 5, so that's still greater than 2. One more iteration, we end up with we looked at the 3 papers, top 3 papers, and we find that the minimum citation number is 3 here. So this alone does not tell us this here particular case here is telling us this person indeed have a H number that's H index 3. Just to try to show you what if we do one more iteration. Now we look at the 4 paper and the minimum citation here is 1. So if we want to claim that this person have a H index 4, we have the problem because the fourth most cited paper have a citation number 1, so that contradicts to this definition here. So based on this kind of enumeration example, you can see that the brute force solution is going to look for the right hand side towards left hand side. The first time we see this the violation, the paper we looked at, the number of paper we looked at is greater than the minimum citations we have. That's the time it's telling us we should go back 1 step and just grab that number instead. So basically, if we compare the quantity on the left and the quantity on the right hand side, it's telling us the direction we can try to look for the H-index. So the follow-up here is asking us to implement an algorithm that's in logarithmic sense. So instead of doing this brute force right-hand side toward left-hand side linear scan, we could apply binary search based on these 2 quantities. So just be a little bit concrete, what exactly are the 2 quantities we're looking at? We have looked at. The left-hand side is the number of the top k papers, top k cited papers. How do we derive this number? It's basically the if this this element we're looking at have an index I, here is 2. So the 3 is basically in the total number of paper subtracted by I, and we want it to be less than or equal to the right hand side, which is the array number at here. So what we're looking for is the smallest I such that this condition still holds. So that's basically how we want to apply binary search. Note that the tricky part for this problem is that let's say that I'm a pretty newbie researcher. All my I published a few papers, but I'm brand new. All the papers I published have zero impact. The citation is just going to be 0 everywhere. This will always satisfy. This will never satisfy. So this condition will never satisfy. So if we don't handle this boundary case, we will end up return something that's not the correct answer. So we just have one thing to handle the special case. We can detect this special case when the very last paper, the most influential paper, still have 0 citation. So for that case, we can just return 0. That person have no impact whatsoever. So the index h-index number is 0. That's the special case. After handling that, we can just apply binary search. Try to look for the smallest I, such that this condition still holds. So with that, we just implement the code. So let's just handle the special case. Oh, another special case is if I don't publish anything, I have 0 impact. So if this is empty, or the most influential paper have no impact, I should just return 0. Otherwise, I will apply binary search to find the smallest I such that this condition satisfies. So it's the rest of the code is going to be pretty much a standard binary search. So we want to find the leftmost, the smallest I. So we're just going to test it on the contrary. So if I'm in this kind of situation, that means I'm overshooting the I. So I should up the lower bound to be at least I plus 1. Otherwise, I will set the upper bound to be exactly I, because I can potentially be the number I'm looking for. So in the end, the while loop will terminate once the lower bound and upper bound become equal. So I will just return either one of those. So that should be the code. Yeah, it's accepted. The tricky part is to handle the special case. No impact, no h-index. So that's the physical meaning about this boundary case. So that's the question today.